Hello again, students. It's another day on EduTech X, and I'm so excited to see you guys in our math class today. We are done with our previous topic or our previous lesson, which was linear equations. Well done, guys. You've done so well with with following us through that particular lesson. But today we want to discuss something different. And the topic we want to discuss is Surds. The topic we want to take a look at in today's class is Surds. Have you ever wondered that we can apply Surds in our African setting? Oh yes, we actually can. And that is why it is very essential or very important that you follow us through this important lesson, which is Surds. And that is also the reason why we at EduTech X, especially on this math platform, want to take a look at Surds. And just like we said, in our African setting, this particular topic is very important because we can apply it in carpentry, we can also apply it in dressmaking, we can also apply it when we are making maths or even painting. And you can clearly see its significance in our African setting with the examples we've just given. But then again, what do we mean when we say sets? So let's take a look at an example on the board, or let's take a look at an expression on the board that will give us a fair idea about what sets are. So you can see the expression on the board. Oh, it's not 9 under the square root sign. It's actually A, the alphabet A. So it's not 9, it's A. So whenever there is a number under a square root sign, then that number or that whole expression is what we term as a surd. Again, whenever you have any number under the square root sign, we term that as a surd. And there are certain terms that we will come across through this lesson that we need to pay attention to. So we want to discuss one of those terms or explain one of those terms, which is perfect squares. Again, perfect squares. So what do we mean when we refer to the term perfect squares? So let's take a look at it. So we have some numbers that when you place them under the square root sign, they give you a whole number as an answer. Again, there are some numbers that when placed under the square root sign, they give you a whole number as an answer. And these numbers are what we refer or term as perfect squares. So what are some examples of a perfect square? So one example is 4. Why are we saying 4 is a perfect square? So let's try putting 4 under the square root sign and see whether we'll get a whole number or not. So when you put 4 under the square root sign, your answer will be, yes, the answer will be 2. Your answer will be 2. And mind you, 2 is a whole number. So therefore, we can term 4 as a perfect square. Let's try taking a look at another example. Another example is 9. Let's take a look at it as well. So we place 9 under the square root sign. And what answer do we get? Yes, we get another whole number, which is 3. So because the answer we are getting is a whole number, 3, then we can refer to 9 as a perfect square. Now let's take a look at another example to try and then understand what we are talking about really well. Another example we have there, or we have 2 being put under the square root sign. Now, what answer do we get over here? Do we get a whole number? No. When you put 2 under the square root sign, you'd get a fraction. It's not a whole number, so we cannot say 2 is a perfect square. So examples of perfect square that we have are 4, 9, 16, etc. So we can only refer to a number as a perfect square if when placed under the square root sign, it gives us a whole number. Now let's take a look at another term used in sets. And that term is square root. That term is square root. Now, what do we mean by a square root? Square root is the sign that we see expressed on the board. So the sign that is boldly written on the board is called a square root sign. So with this particular sign, you can place any number under it. But remember, just like we initially said, if you place a number under it and the answer gives you a whole number, or you get a whole number as an answer, what does it become, or what do we term it? Yes, you remember, or you remembered, it is called a perfect square. That's very good. So when we write the square root sign, we can place any number under it, just like we've initially said, 2, 3, 20, 5, whatever number, and that will be a surd. So can you also give me an example of a surd on your own? I know you provided a perfect answer. Well done. This shows you are following the lesson. Very good. Now, the problem is sometimes these sets are given to you in a simpler form, like you can see on the board, square root of 2, square root of 3. These are much easier to work with. But what if complex ones are being given to you? Complex sets. How do we go about it? How do we simplify such complex sets? So an example of a complex set can be square root of, say, 50. It's a complex set. So the question is, how do we simplify it? So that's what we want to focus on at the moment. We want to discuss how to simplify complex sets. So with questions like these, they are very easy. They are easy when you follow the steps we are about to discuss. So you first of all think about which number or which numbers you are going to multiply in order to get 50. But mind you, you must make sure one of those numbers is a perfect square. So you are going to have two numbers multiplying each other to give you 50, but those numbers or one of those numbers must be a perfect square multiplied by another number which is giving you the number under the square root sign. So that's what you must think. Okay, so I have a perfect square, say 4 or 9. What number am I multiplying it by that can give me 50? So that is your job to do. That is something you must do. So with this particular question, we can have a perfect square like 25. So we think which number multiplied by 25 would give us 50? Yes, 25 multiplied by 2 will give us 50, right? And you have one of those numbers, which is 25, being a perfect square, and the other number not being a perfect square, which is 2. So let's express that on the board so that we can get what we are trying to talk about. So we have square root of 50, which is the complex set, equals to square root of 25 multiplied by 2. So in actual fact, we've been able to split 50, which was a complex number, into two simpler numbers, which is 25 and then 2. So after doing this, what will be the next step to do? The next step will be to isolate the two expressions, which is square root of 25 and then square root of 2. It's very important to do this. You need to isolate those two numbers. So can we get an answer for square root of 25? Yes, remember square root of 25 or 25 is a perfect square. So the square root of 25 is going to be, or the answer is going to be, yes, 5 multiplied by the square root of 2. Mind you, 2 is not a perfect square, so you would have that surd remaining. Now, what's the next step to take? Now, remember that 5 with the multiplication sign and square root of 2 is just like you are writing 5 root 2 or 5 square root of 2. So that is how you express it, like we've done on the board. So we said that when you have a complex set and you are asked to simplify, what do? You first find two numbers, which when you multiply will give you the number under the square root sign. But one of those numbers must be a perfect square. After getting those two numbers, you make sure you isolate those two numbers or those two sets, and then get the answer for the perfect square and then multiply it by the other number which is not a perfect square.